The first problem is asking, use the sum, difference, or double angle formulas to find the exact value of each of the following. There are a bunch of ways that you can find the sine of 75 degrees. Remember, 75 degrees are equal to two known angles, 45 and 30 degrees. Or you can write 75 degrees as 150 degrees divided by 2. And if you remember, 150 degrees is basically 180 degrees minus 30 degrees divided by 2. And I think, and I kind of like this somewhat, the summation over here. And so I'm going to write it as sine of 45 degrees plus 30 degrees. Using the sum formula, I get sine of 45 degrees times cosine of 30 degrees plus sine of 30 degrees times cosine of 45 degrees. Sine of 45 degrees, if you look at your table, is square root of 2 over 2. Cosine of 30 degrees, square root of 3 over 2, plus sine of 30 is 1/2, times cosine of 45 is the same as its sine. I can put this as square root of 6 over 4 plus square root of 2 over 4, or square root of 6 plus square root of 2 over 4. The next part is asking to compute cosine of 2 or cosine of 3/5. So my problem is, first of all, I have to figure out what this angle is. And that is, before that, I need to figure out what angle is arc cosine 3/5. According to what I know, if theta is arc cosine 3/5, then cosine of theta is 3/5. 2 theta. And I have to find cosine of 2 theta. So what is the formula for cosine 2 theta? Cosine 2 theta is equal to cosine squared theta minus sine squared theta. This is telling me not only I need cosine theta, I need sine theta. And you can do it multiple ways, but one way is this. Cosine theta is in the right triangle. I can write adjacent over hypotenuse 3/5, and then compute the opposite. Opposite is going to be square root of 5 to power 2 minus 3 to power 2, and that is not 4. So sine theta, which is opposite over hypotenuse, is 4/5. Now go back in here and putting 3/5 to power 2 minus 4/5 to power 2, and that is 9 over 25 minus 16 over 25, and that is minus 7 over 20.